My name is Dr. Gregory Kriehn, and I am an associate professor within the Electrical and Computer Engineering Department in the Lyles College of Engineering at Fresno State. I am participating in the 2013 Summer Teaching Innovations Academy, and I'm looking at redesigning our ECE 71 Engineering Computations course. ECE 71 is a fundamental C programming course that is required for electrical and mechanical engineering students. The class has traditionally had a high D in failure rate, since the course material is out of major for mechanical students, and both mechanical and electrical engineering students typically dislike programming. Besides a lack of motivation, most students have no programming experience, and several of the later programming concepts in class are quite complex for novice programmers. Students therefore not only struggle with syntax, but also more fundamentally with the algorithmic, logical, and sequential thinking needed to successfully solve complex computational programming problems. I would like to transform ECE 71 using the supplemental model mentioned in NCAT by adding out-of-class activities and changing some in-class activities. Since C programming is highly technical, out-of-class activities such as online lectures and YouTube videos may help teach students fundamental programming concepts such as data types, sequential and conditional statements, loops, arrays and pointers, structures, and file I/O. Activities in class can then be focused on programming examples with students in the engineering computer labs. The focus will shift toward addressing students' logical and syntactical errors, which will help them adapt more quickly to efficient programming techniques. Over the years, I have been slowly transforming the delivery method for the class. When I first arrived at Fresno State 10 years ago, the department taught ECE 71 as a pure lecture course from within a traditional classroom environment. I quickly realized that the best way to teach students how to learn a new programming language is to use the same methodology used to teach people how to learn a new spoken language: direct cultural and language immersion. So I moved class into the engineering computer labs, which afforded students the opportunity to work more directly with the computational tools used to develop their source code and compile their programs. Opposed to just using a basic text editor for developing code, I also began incorporating the use of an integrated development environment, or IDE. Both of these changes have helped immerse students into programming, but there's still only so much time that can be devoted to hands-on, in-class programming activities when most of the class period is devoted to the lecture material. I'm looking forward to increasing these activities with the proposed changes to the class. As an electrical and computer engineer who has spent the past 20 years immersed in computing technology and software, I consider myself quite adept at interfacing and adapting quickly to new technology. But one of the biggest things I learned at the Teaching Academy is how to use Google Drive to create a real-time collaboration environment. Google Drive allows for third-party additions, and today I found a company called Neutron Drive that has created a coding development environment that allows for real-time collaboration, code revision control, syntax color highlighting, and auto indentation from within Google Drive's base platform. I'm particularly excited about an easy way to introduce code revision control to the students within this environment, since students often overwrite working programs with code that no longer works, and they cannot figure out which changes broke their code. With code revision control, students will have a working history of all prior revisions of their code, which should help them with some of their debugging problems. I have tried introducing formal code revision control in ECE 71 in the past with programs such as Subversion and Git, but for students first learning how to program, it was too overwhelming. Because Neutron Drive uses Google Drive's collaborative real-time environment and adds a programming editor with code revision control, it provides a much simpler solution for students in the class. The biggest concern that I have about my course redesign for ECE 71 is the time required to develop video lectures. I have searched for existing online C programming lecture material, but most of it is written from a computer science perspective opposed to a computer engineering computational perspective. This means I will have to develop most, if not all, of my video lectures. Using FF, MPEG, and Linux to perform screencasting with lecture slides and the NetBeans IDE to demonstrate coding examples is fairly straightforward, but I am concerned about the amount of time it will take to edit the video content into something usable. Hopefully, it will not prove too overwhelming. Thank you for listening to my course redesign plans for ECE 71 at the Fresno State Summer Teaching Innovations Academy.